Can you introduce yourself and give an overview of Cartesi?
Of course, yeah. So I'm Max. I do ecosystem growth for Cartesi. Cartesi is a rollup infrastructure project aiming to facilitate developers in building app-specific rollups. Another important factor here is that we have a custom virtual machine that is non-EVM, and actually it's based on RISC-V, which is an open standard instruction set architecture. It's very similar to the CPU you have in your computer or phone, and that actually allows us to run traditional programs in a decentralized way. We can actually even boot a full operating system. So we're actually booting Linux as well on top of this VM.
What's the story behind Cartesi, like the origins?
Yeah, so Cartesi started about 4.5–5 years ago. The origins were that the founders wanted to actually create an AI marketplace and realized that there was no infrastructure yet at the time. They come from a mathematical background, a research background, and wanted to sort of enable such a use case. So what they started with is actually really this virtual machine, which I started describing just before that, which is a virtual machine that is very similar to a traditional computer. And we started off with something called Cartesi Compute nowadays, which isn't a rollup actually, and is more of a computational oracle where you can send a certain input into it. It computes, it calculates stuff for you, in this interesting virtual machine that we're describing, and throws back an output for you. Now we, in the last years, we've sort of focused our attention a bit more on rollups, as this is clearly something that has a lot of interest in the Web3 space. And rollups, on that side, the goal is to sort of evolve state, right? Have sort of a continuous application running, sort of forever if you want. Yeah, that's sort of the story of Cartesi.
Okay. So what are the main issues you try to solve, and do you have some use case about Cartesi?
Yeah, so the main issue here is that when you look at Ethereum or the EVM today, it's we like to say it's sort of like a pocket calculator, right? It's we call it the world's computer, but actually it is a very limited computer in terms of what you can do on top of it, right? You're kind of limited to like one flavor of machine code, which is Solidity, and you can't really tap into like a bunch of other languages, abstractions, and you can't do complex things. So really the goal here is to allow you on one side to have sort of the computational capacity of a full CPU, because every application has its own rollup, its own VM. It's not sharing that with anyone else, while still having the security guarantees of Ethereum, right? That's an important factor to mention. So we're optimistic, meaning that we actually run things on top of Ethereum, off-chain in a deterministic environment. And if there's a disagreement, we will rerun it on Ethereum. And on Ethereum, as you know, there's global consensus with lots of validators. So you kind of inherit that security, basically.
Could you explain, like in a simple way, how does Cartesi technically works?
Yeah, of course. So imagine that we were playing a game of cards, the two of us, right? So I'm playing a game of cards on chain, and instead of running that on Ethereum, where it would cost a lot to to sign a transaction for every move, it would be very expensive to play that game. We actually run it off chain in a deterministic machine. And deterministic means that it's an environment where, given a certain input, we should always get the same output. And as I said, this deterministic virtual machine that we have is RISC-V based, so it's emulating a traditional computer, right? Which is the sort of VM component. But let me focus on the optimistic side right now. So we play a game of cards. If we agree on the result, perfect. We can post the result to Ethereum, and practically we should be getting the same result unless one of us is being dishonest. If, however, one of us is being dishonest, what will happen is that one of us will basically submit a fraud proof to Ethereum, and that all happens automatically, right? And then once we submit a fraud proof on Ethereum, we will narrow down to the specific part of the game where we disagree and rerun that part on Ethereum. And on Ethereum, as you know, there's thousands of nodes. So we end up using Ethereum basically as an arbitration mechanism to sort of see who is honest and dishonest, and basically punish the dishonest validator. Now this is the optimistic roll-up side of things. Basically, it's an optimistic consensus, if you will. On the VM side of things, as I mentioned, we're basically emulating a RISC-V instruction set architecture and removing all the non-determinism from that, so that it's deterministic, right? And as I said briefly before, RISC-V is very similar to a CPU architecture that we have in traditional computers nowadays. It has a large community and is open source, hence why this was chosen. And having a RISC instruction set architecture actually allows us to do a lot of things that we can't do normally. So we can run traditional programs, we can run an operating system like Linux, we can use basically all programming language that work on Linux, but not only the programming languages, also the ecosystems that are built around those languages, right? So we can tap into complex libraries that were written in C and C++, in Python, and this really opens up not only the space to more people, but also really unlocks completely new use cases, because you don't have to reinvent the wheel. You can use existing abstractions and build from there.
Okay. And who are your main type of customers or users?
That's a great question. So I think that it's sort of a huge design space, right? You can run, as I said, traditional programs on this. So this could apply to anyone that wants to do more complex things, right, on a blockchain, in a verifiable way. So, for example, in DeFi right now, we're quite limited in terms of what we can do, because we have to limit our interactions with the blockchain as much as possible. We have this block space competition. So, in times of high demand for block space, certain use cases are completely outpriced. As you know, when there's a big NFT drop or a new meme coin, everyone is sort of impacted, right? So here with application-specific rollups, on one hand, you can run really complex things. Say you wanted to do an order book exchange, for example, with some risk modeling happening, fully decentralized in a verifiable way. That could be an interesting option. And on the VM side of things, right? Since you can use all these languages, libraries, abstractions to build things, again, you can do more complex things. So for this example of an order book exchange, for example, you would be able to use a matching engine that is being used by centralized exchanges today, right? Written in C++, for example, to do the matching of your orders in a fully verifiable way again. But again, I mentioned DeFi, but it's just an example. You can run games, you could do stuff around IoT related things, you could do basically decentralized compute, verifiable compute, which is a huge sort of space, right?
Perfect. Do you have recent milestone or partnership with other companies or projects?
So we're nearing to our first phase of mainnet, which is basically, since we're app specific, right? There's not one sort of large rollup environment where everyone can deploy on top of. Everyone actually would deploy their own rollup. So an important milestone here is that we will actually have a first application, an app-specific rollup that we will deploy in the near future. It should be in a couple weeks. That basically will, we call it a honeypot application, which will be filled with money, and people can try to crack it and basically extract, any value that is lying there. And this is sort of our way of testing the system, and also of, sort of doing some form of decentralized auditing, if you will, right? Because whatever you take from the Cartesi rollup here will be yours afterwards.
Okay. So to conclude, what is Cartesi vision for the future of blockchain? How do you plan on keep on the innovation?
Yeah, so Cartesi's vision for the future of blockchain is a blockchain system that is very similar to, existing compute, right? If you think of something like AWS, that's something people are very familiar with. We can build very complex applications using SaaS cloud servers. Now imagine if we had the same programmability and the same capabilities as we have, or very similar capabilities as we would have there, but for decentralized application, right? For verifiable compute. So that's really Cartesi's aim and vision. And we're a very decentralized project. We're building. This is open source software that is being built, and we're inviting anyone to come and contribute in different ways as well to this ecosystem and to this vision.
Perfect. Thanks a lot.
Thank you.